Separating the components of panacetin. Accurately weigh about 3.00 grams of panacetin and transfer it to a clean 125 ml Erlenmeyer flask that is dry. Add 50 ml of dichloromethane to the flask. Stir the mixture thoroughly with a glass stirring rod to dissolve as much solid as possible, using the rod to break up any lumps or granules. Using a pre-weighed fluted filter paper, filter the mixture by gravity into a small flask, saving the filtrate, the liquid that goes through the filter paper, for the next step. Set the filter paper aside, being careful not to lose any of the sucrose, and reweigh it when it is completely dry. Record the mass of the sucrose in your laboratory notebook. If requested, submit the sucrose to your instructor to a tiered and labeled vial. Transfer the filtrate to a separatory funnel and extract it with two separate 25 ml portions of aqueous 1 molar sodium hydroxide. Because the dichloromethane layer will be on the bottom, you will have to transfer each layer to a different container, label the containers, and return the dichloromethane to the separatory funnel before the second extraction. Combine the two aqueous extracts in the same container and save the dichloromethane layer for the following step: isolation of the unknown component. Slowly add 10 ml of 6 molar hydrochloric to the combined aqueous extracts while stirring with a glass stirring rod. Test the pH of the solution as described in experiment 1 and add more acid if necessary to bring the pH down to 2 or lower. Cool the mixture in an ice water bath for at least 10 minutes. Collect the aspirin by vacuum filtration and wash it on the filter with cold water. Let the aspirin dry on the filter for a few minutes with the aspirator running, then dry it to constant mass. Weigh the aspirin and record its mass in your lab notebook. Submit the aspirin to your instructor in a vial labeled as described in experiment 1.